Metals are physical properties we are carrying along. Metals are good electrical conductors. Metals are good electrical and heat conductors. And the reason behind basically is behind both electrical conductivity and heat conductivities, metals got free electrons. It means we need to know about metals metallic bond. Okay. Typical general metal, all metals basically, they have a metallic bond. And the metallic bond means they have metal atoms, which are basically not atoms, rather they are positive ions. Metals cations, because a famous saying, phrase, a theory, metals last electrons are basically delocalized, mean they are out of their shells, moving around, overlapped all the last valence shells. So metal atoms have delocalized electrons surrounding them, electrons, delocalized electrons. Okay, so it means between metals cations and sea of electron there exists a strong electrostatic force of attraction that is responsible for metallic bond. Strong electrostatic force of attraction. Obviously between metals cations, between metals positive charge centers, cations, and sea of electrons. Makes metallic bond. Strong electrostatic force of attraction between metals cation and sea of electron makes what? Metallic bond. Okay, that strength of the metallic bond varies from metal to metal depending on the nature of the metal, depending on how much electron they release. Like sodium has atomic number 11, mean 281. So its metal atoms are charged as 1 plus ions, only one delocalized electron per atom. But you check aluminum atomic number is 13, 283. It means it turns to Al3 plus, normally stays as. So it contributes 3 electrons per atom. Electrostatic forces of attraction between sodium 1 plus and 1 minus are much weaker as compared to aluminum's 3 plus and 3 minus. So that makes aluminum as a much better electrical conductor, heat conductor, and got more strong metallic bonds, stronger attractive forces, and it has better tensile strength. That is why aluminum is used much as construction rather than sodium, which is kept under kerosene oil because of the reactivity. Anyhow, when we say why metals are good heat conductors and electrical conductors, the reason behind is they have delocalized electrons. The free electron word may not be that good to use, but they have delocalized electron. So when a difference of potential is applied, okay, there is a negative terminal of the battery and positive terminal of the battery, the current can move through the metal. It will not move through the plastic, it's insulator. It will not move through the wood, because when you apply difference of potential, metals electrons get directional. They rush to the positive terminal. So the more electrons are basically fed in from the source, and electrons start moving from negative terminal to positive terminal. More electrons are being fed in from the source, but metals cations stay at the place. So what happens basically when a difference of potential is applied? When a difference of potential is applied, electrons of metal get directional and rush to the negative terminal. Metals cations stay at the place. Stay at the place. Only the electrons get directional. So difference of potential when you apply electrons of the metal already present, they get directional to the positive terminal, so the space which is created is filled in. Metallic bond never dies, it stays there, okay, and metals cation actually stay at the place. So it means in an MCQ normally they ask what happens. You need to know electrons get directional but positive ions stay at the place. More electrons are fed in from the source, sort of EMF generated. And for 1 mark, if they ask what actually is responsible behind the electrical conductivity, you say delocalized electron they have. They are conductors, they have delocalized electron. Graphite is a conductor, it has delocalized electron. But ionic compounds get conductor only when the ions are free to move, like in molten or in aqueous form. Okay, so metals are heat conductors as well because of delocalized electrons. Reason, when a part of the metal is heated, suppose this part, its electrons get heated up and they transfer their energy to the others and a sort of electron diffusion takes place. So that is why a metal gets heated up very quickly, okay, but the electrical conductivity or heat conductivity both is dependent on the fact they have a strong metallic bond that it maintains, it remain intact during all that process. So after switch on and off, nothing happened to the wire, or after cooking on a cooking utensil, nothing happened to that pot because only the electrons are playing their part. In electrical conductivity, they rush to the positive terminal and more are sucked in. Heat conductivity, they also are involved in hot electron diffusion. Hotter electron move to the colder place, transfer their energy, and others basically are being heated up constantly. So they are heat conductor and electrical conductor. That is another very useful property of metals.